Today's lesson is about the basics of calculating the probability of something happening. Your basic formula for probability is this. Count up the number of items that you care about calculating the probability of happening and divide by the number of total options possible. Fill that in because that will be super important today. Now, a really quick example of this is calculating the probability of getting ahead on a coin toss, heads or tails. There's really only two options in a coin toss. So your total number of items is 2, and only one of those is possibilities is getting heads instead of tails. So really your probability of flipping a coin and getting heads is just 1/2. One being the one option of getting heads to the total number of options. Now, usually it'll take a little bit more work than that. Sometimes you'll have to sum things up to figure out what your total number of options are. For example, question 2. A bag contains 6 red marbles, 3 blue marbles, and 1 yellow marble. Find the probability of choosing a red marble. So let's figure out what our total number of marbles are. There are 6 red ones, 3 blue ones, 1 yellow one. Add that up, there's 10 marbles. And then we need to reread the problem to figure out how many of those items are red marbles, since that's what we are trying to calculate the probability of getting. The intro said that the bag contains 6 red marbles. So when we put it all in our probability fraction, number of items that are red marbles over total number of items, it's 6/10. Quick note that if you get a probability fraction that can simplify, for example, this 6 and this 10 can both divide by 2, then you must simplify that fraction. So your final answer is that the probability of blindly choosing a marble from the bag and getting a red one is 3/5. If you choose 3/5 times, you'll probably get 3 red marbles out of those 5 tries. I want you to pause here and calculate the probability of choosing a blue marble on your own. Go ahead and check your answer. There's still a total of 10 marbles in the bag. That hasn't changed. But there's only 3 of them that are blue. 3/10 doesn't simplify, so that's it. You've got a 3/10 chance of choosing a blue marble. Now, one type of probability is called experimental probability, and it's making predictions about the probability of something happening in the future based on an experiment run in the past. Here's an example. A quality control inspector for office suppliers checked a sample of 250 markers and found that 14 of them were defective. Find the experimental probability of choosing a defective pen. So, if you read that carefully, it tells us what the total number of items or total number of markers are, and then it also tells us the number of markers that we care about in terms of calculating the probability. They ask us to calculate the probability of choosing defective markers. You put it all together in your fraction for probability, 14 markers you care about in the defective category, 250 total, and then because they're both even numbers, you could divide them both by 2 to simplify the fraction. Question 4. You roll a 6-sided number cube. Part A, probability of rolling a 3. Now, a 6-sided number cube is really just a fancy way of talking about dice. So if you think about dice and how many options there are 6 sides and the numbers on each side range from 1 through 6. So when you're calculating your total number of options of numbers you could roll with the 6-sided number cube, there's 6 options. 1, 2, 3, 4, 5, and 6. The probability of rolling a 3, only one of those sides has a 3, so that's one option that is in the category we care about out of 6 total. 1/6. That's your probability of rolling a 3 on the first try. Pause here and try questions B and C for number 4 on your own. So probability of rolling an even number, if you look at your list of options, you have 2, 4, and 6 as your even numbers. Basically every other number was an even number. So that's 3 even numbers out of the 6 total. You put that in your fraction and simplify it. You have a 1/2 probability of rolling an even number. For part C, probability of rolling not a 6. So there's 1, 2, 3, 4, and 5. There's 5 options that are not 6. That's 5 out of 6 for your probability. Now, building off of that six-sided number cube problem, sometimes you'll roll 2 six-sided number cubes or 2 dice. When you do that, this chart's going to be super helpful. So imagine you have 2 six-sided number cubes, one's red, one's blue. Here's the options for the red one, here's the options for the blue one. So when you roll, you might have a combination of the red one is 1, and the blue one got you 1, or you might have a combination of the red one rolled 1 and the blue one rolled 2. And these are all the different possible combinations you could get from rolling your 2 die. That's going to be helpful for problems like this. What is the probability of rolling a double of the same number? So if you look at your chart, look at the pairs of different options you could get for each type of dice and see how many are the same number twice. For example, 1 for the red one and also rolling 1 for the blue one. Go through and circle all the ones that are doubles. Pause here until you've found them all. You should find those pairs of doubles, both 1s, both 2s, both 3s, both 4s, both 5s, and both 6s. That's 6 options that are in the category we care about of doubles. Out of how many total? Well, here's a quick way. You could literally count all the boxes in the chart besides the headings and the labels for the red and blue separately. Or you could just say, well, if there's 1, 2, 3, 4, 5, 6 options in the first row and 1, 2, 3, 4, 5, 6 rows, you could just do 6 times 6 as a shortcut to get how many rectangles are in this box. 36 in other words. So there are 6 doubles out of 36 possibilities total. So 6 over 36 is your probability of rolling a double, but then that simplifies because both 6 and 36 can divide by 6. So you have a 1 out of 6 probability of rolling your 2 die and getting a double. So now I want you to try part B on your own. Go through and circle all the numbers that add up to 7 in each box. For example, here, if the red dice is 6 and blue dice is 1, that adds up to 7. Are there others? Circle all the ones you could find. Pause here until you've found them all. One thing you'll notice is that with a lot of these probabilities with this sort of chart, the ones you circle will be in some sort of pattern. For example, a diagonal line like here connects all the pairs of numbers that add up to 7 in one roll. There's 1, 2, 3, 4, 5, 6 different options that can add up to 7. So you'd say that's 6 out of 36 again, and coincidentally it's the same answer as the previous one. That won't happen very often. Probability of getting an even sum, adding up the two numbers in the box and it adds up to an even number like 2, 4, 6, or 8. So here's the first row. 1 plus 1 is 2, 3 plus 1 is 4, 5 plus 1 is 6. So those would be circled, but the ones in between added up to odd numbers like 2 plus 1 was 3, so you skip those. Go through the whole chart, circle all the ones that add up to an even answer. Pause until you're done. When you're done, it should look like that. 18 of those summed up to even numbers, 18 out of 36, actually simplifies to 1/2, which actually makes sense because you could predict that it would simplify to 1/2 since every other one was a circled even number answer when you summed it up. If it's every other, that should add up to about half when you do the math. So you have 1/2 or 50% probability of rolling the pair of dice and getting an even sum. Pause here and try the next two on your own. Check your answer for part D, probability of getting a sum of 12. There's really only one single box that when you add up the pieces it gets you 12, and that's the 6 plus 6 box. So you'd have to roll a 6 with both dice to have the numbers add up to 12. There's no other way you could get to 12. So that's only one out of your 36 options. So a pretty low probability of rolling something that would add to 12. Now the probability of getting a roll that adds up to 6 is a lot higher because several boxes add up to 6. You should get 5 out of 36 for that, and that doesn't simplify, so that's your final answer. Great job today, everybody. Don't forget to turn in a picture of your notes on Schoology now that you're done.